Financial Maths 2017 Leaving Cert Higher Level Paper 1 Question 8. A loan P with equal repayments A at the end of each T periods of time, where I is the periodic compound interest rate, is given by this amortization formula. A is equal to P times I times 1 plus I to the power of T over 1 plus I to the power of T minus 1. You're asked to derive this formula using the sum of a finite geometric series to help. So the sum of a geometric series, sum of n payments, A or n, whatever n may be, 1 minus or to the power of n over 1 minus or. We're going to use t here. We're going to n is equal to t in this case. They've given us t. So if we reverse the order of these payments, they're going to become less valuable. A over 1 plus I will be the last payment. A over 1 plus I to the power of 2 will be the second last payment, and so on. And this is in reverse. First payment, A over 1 plus I to the power of T. So we do it in reverse here. So we have A in simple terms. This is my little a. Or the common ratio, I have to multiply each term by 1 over 1 plus I. So now we just fill this information into Sn. So the sum of n payments is my loan amount, which is P. So P is equal to A, which is A over 1 plus I, times 1 minus or, which is 1 over 1 plus I, to the power of T in this case. And that's going to be over 1 minus or, which is 1 minus 1 over 1 plus I. So if we just simplify both of these brackets, 1 over 1 plus I to the power of T, well, 1 to the power of anything is 1, so it's just 1 over 1 plus I to the power of T, and the bottom, this one, that's this bracket here, just this part of it. So we'll simplify the top first, A over 1 plus I times, we're going to have 1 minus 1 over 1 plus I to the power of T. And then the bottom we can simplify now, just off to the side, and then fill it in. So if we imagine they're both fractions, we have 1 plus I by 1, 1 plus I, minus 1 by 1 over 1 plus I. So you can see here we're just going to end up with I over 1 plus I, which we're going to turn upside down, and these 1 plus i's, this one will be on the bottom, this one will be on the top, and they'll cancel. So P is equal to A over 1 plus I. You could do it in a couple of smaller steps. Cross multiply with inside this bracket, we're going to get 1 plus I to the power of T minus 1 over 1 plus I to the power of T times 1. Don't need the 1. And I can bring this guy up now and turn it upside down, multiplied by 1 plus I over I. So these cancel. Now we're looking for A. If you go back up to what they're looking for A. So we need to just cross multiply. So we'd have P by the bottom, P by 1 plus I to the power of T by I equals A by 1 plus I to the power of T minus 1. Now I just want A, so A is equal to P times I times 1 plus I, we give it in the order they want it in, to the power of T, over dividing by 1 plus I to the power of T minus 1. If we go back up, this is what they were looking for. P times I times 1 plus I to the power of T over 1 plus I to the power of T minus 1. So that's it. Finished. A real handy formula to know how to manipulate. Part B of this question starts off with two easy ones. Alex has credit card debt of 5,000. Fixed repayment at the end of each month is 2.5% of the original debt. What's the fixed amount? Well, that's 5,000 by 2.5%. So 5,000 by 0.025. It's going to give me an answer of 125. 1% is 50. 2% is 100. 2.5% is 125. The annual percentage rate charged by debt by a credit card company is 21.75%. So a reason not to have a credit card. Fixed for the term of the debt. Find as a percentage. It's this symbol. Correct the three significant figures. The monthly interest rate that's equivalent to an APR of 21.75. Well, you guys have practiced loads of these. So 1 point the interest rate. So 1.2175 to the power of 1 over 12. We're looking for monthly. It's going to give me an answer of 1.016535. Now you can estimate here, if it was 24%, it'd be approximately 2%. So a little bit less than 2%, 1.6535, and three significant figures is just the 1.65%. Part 3, assume Alex pays the fixed monthly payment, A each month. We got 125, didn't we, up here, 125. Just jot that down, 125. And does not have any further repayments. Complete the table below. To show the balance on the debt of 5,000 is reducing each month for the first 3 months, assuming an APR of 21.75 from the previous part. So these are the numbers we're bringing down. And we're given this table where we're given some numbers, some shaded in boxes, and we're asked to complete the table. So the fixed monthly payment is 125. So that's going to be in all boxes. It's not changing. So how do we get to this figure 4250? Well, we have an interest. The interest is on the 5,000. So 5,000 by 0.0165 is equal to 8250. So that must be the interest here, 8250. And you can see if we take 8250 away from 125, we're going to get 4250, which is what the balance is reducing by. So now the interest on the next payment is not going to be on 5,000, it's going to be on this guy here. So let's get 1.65% of that. 81.79875, so 8180. 8180. So that's this number. Taking 8180 away from 125, we're going to get 4320. And taking 4320 away from 49495,750, we're going to get 491430. Now I need to get the interest on this. So 1.65% of 491430 rounds off to 8109. Taking 8109 away from 125, we're going to get 4391. And taking 4391 away from 4914, we're going to get 4870.39. An unusual type of question, more a business studies type question than Leaving Cert higher level maths, but you have to be ready for all eventualities. Part 4 of this question, you're told, using the formula derived in Part A, find how long it would take to pay off the credit card debt of 5,000 using the repayment method outlined at the beginning of Part B. So this is the 125 a month, and my formula A is equal to P times I times 1 plus I to the power T. So we're going to be using logs here because we're looking for T, over 1 plus I to the power T minus 1. So if I fill my information in here, that's A. I, we got to be 1.65%, so 0.0165, and the loan is 5,000. Okay, so we're going to have 125 equals 5,000 times 0.0165 times 1 plus I, so that's 1.0165 to the power T, divided by 1.0165 to the power T minus 1. So we do one thing at a time. I can multiply the bottom by 125 or cross multiply, so we're going to get 125 by 1.0165 to the power T minus 125. That's equal to 5,000 by 0.0165, which is 8250 from above. by 1.0165 to the power of t. So I need to isolate the t's, so I can bring the 8250 one to the left and then factorize. So 1.0165 by to the power of t by 125 minus 8250 by the same thing. So we can factorize the t out and the 125 off to the right. So we're going to get 1.0165 to the power of t times 125 minus 8250 equals 125. So that's going to give me, is that 3350? No, 4250. So 1.0165 to the power of t is equal to 125 over 4250. This guy's 4250. So as a decimal, well, I don't need to, I'll leave it like that and we'll use our log rule. So t by the log of 1.0165 is equal to the log of 125 over 4250. So t is equal to the log of the right hand side divided by the log of the left, 1.0165, and on a calculator this gives 65.92. And rounding this off, this is in months. We get t is equal to 66 months. In part 5, we're told Alex decides to borrow 5,000 from the local credit union to pay off the credit card debt of 5,000. The APR charge for the credit union loan is 8.5% fixed for the term of the loan. 8.5, we're borrowing 5,000. The loan is to be repaid in equal weekly repayments. So this we're going to do 1 over 52 to get the interest rate at the end of each week. Find the amount of each weekly repayment. Okay, we're looking for A is equal to P times I times 1 plus I to the power of t over 1 plus I to the power of t minus 1. So we need A. P is equal to 5,000. T is equal to, what are we looking at? 3 years. Did I write the years in? I left it out. 156 weeks. T is 156. And I is equal to 8.5%, 1.085 to the power of 1 over 52. That will give me my I. So that gives 1.0. Does this give 1.00157? 00157? Followed by 2 zeros and 2 sevens. So we can round it off to this. So my I is 0.00157. Just fill this information in. A is equal to 5,000 times 0.00157 times 1.00157 to the power of 156 all over 1.00157 to the power of 156 minus 1. So it's just calculator use. Now always do it twice on your calculator. So this gives an answer of 36.161. So 3616 is the amount. Part 6, how much will Alex save by paying off the credit card debt using the loan from the credit union instead of the payment in part B? Okay, what do we have in B? We had 66 months and that was 125 a month fixed payment, wasn't it? Yeah. So 66 a month, or 125 for 66 months, just double check. 125 for 66 months is equal to 8250, and we have 3616 a month, and that was for a week for 156 weeks. And that's 5640.96. So it's just the difference between these two numbers. 2609.04. So quite long financial maths question. Keep practicing.